Alright, we're doing 5-3, monomial factors of polynomials. So monomial is, one term. And polynomials, multiple ones, a bunch of monomials put together with an addition or subtraction. So we're going to be doing monomial factors of polynomials. And we know factors are numbers that can multiply to equal something else. And if it has variables in it, then your factors are going to have variables in it. So we're going to go from there. So we're going to kind of work up towards that. So we want to remember that if we were to have a plus b over c, we could break this up. We could think of this as 1 over c times a plus b. Why? We can think about the distributive property. So right here, 1 over c times a, you can think of that as a over 1. That equals a over c. And then we have plus 1 over c times b over c. So really we started with a plus b over c, and we ended up with a over c plus b over c. Now this only works, you want to have it as like one term. Okay, so there's very confusing things on what you can do and cannot do with those things. With the denominators and splitting up, but these we can. So we can rewrite this as 5m over 5 plus 35 over 5. Both of those top two terms have to be divided by 5. So from there we can simplify. So that cancels out, 5 and 5, and we're left with just m. And then 35 divided by 5 is 7, so we're left with 7, so we have m plus 7. So what did we do? We broke it up, just using this rule, okay? Broke it up, and then we simplified. So now I'm going to scroll down a little bit more. Second one. Okay, a little bit more, but we're going to just break it up first. 26uv over 13v minus 39v over 13v. And now we have to simplify. So 26 divided by 13 is going to be 2. You can think of it as 2 over 1, but actually, is the u going to stay at the top? It's u over 1. U is going to stay at the top with the 2. And then v and v cancel each other out. So actually, you're going to have nothing at the bottom. Minus, okay, now 39 divided by 13. That is 3. And then v divided by v cancels out to 1, so we're just left with 2u minus 3. Ooh, okay, now example number 3 looks tricky, but it's really not. We just have to break each of them up into the pieces. So we're going to have 3x to the 4th over negative 3x squared minus 9x cubed y over a negative 3x squared. We've got to be careful with our negatives there. Plus 6x squared y squared over negative 3x squared. So we're going to simplify from there. Now our first one, we have a 3 over 3, but it's negative, so the negative is going to stay. It doesn't matter if it's at the top or the bottom. It can go at the top or the bottom. Does not make a difference. Now x to the 4th divided by x squared. So which one's more? The top one is. So 1 would go at the bottom. So that would be x squared at the top, 1 at the bottom, but really that just stays as x squared. Now we got to look here. We have a negative and a negative. A negative and a negative. Doesn't matter which one's on, if it's like top or bottom. Negative, negative makes a positive. So 9 divided by 3 is 6 at the top. And then we have x cubed over x squared. That means that there's going to be an x at the top, so we'll put that next to the 6, and y at the top. So we don't have to put over 1 because they're all at the top. Now if you want to write the over 1 at first to help you, that's fine. Do it. Okay, so now we need to do this one. Okay, so we have negative, or 6 divided by negative 3, that's a negative 2 at the top. Oops. 2 at the top. Then we have x squared over x squared. Okay, those cancel each other out. And then y squared is at the top, so it stays at the top with the 2. So really, we don't have to use any fractions in this one. And there we have it. Okay, so just take it piece by piece. So break it up into the pieces. See that? And then you're going to simplify. Okay. A polynomial is divisible by another polynomial if the quotient, remember what quotient means? Quotient is the answer to a division problem, is also a polynomial. And then factoring a polynomial means expressing it as a product of other polynomials. So product means multiplication. So you're gonna have, let's think of it as this way. You're gonna have, let's say that's a factor. Have that in parentheses times another factor. You could have multiple ones, but that's gonna equal your quotient. If that doesn't make sense, you're going to see it later in just a second. So because it says a polynomial is divisible by another, that's if it's divisible by another, if the quotient is also a polynomial. And then factoring a polynomial means you're going to be basically finding the two products, or it could be 3 or 4 or so on and so forth, that make up the other polynomial. Okay, one method of factoring is GCF. So GCF, we've remembered, is greatest common factor. It is very similar to distribution. We remember the distribution property. And it's the distribution in reverse. We will learn other methods of factoring in this chapter. We're going to do a whole bunch of factoring, but we're going to start right here. So we're going to see what they have in common. What does 5x squared and 10x have in common? We got to find their GCF. Their GCF is 5x, because they both can be divisible by 5. That means they can both be divided by 5 evenly, and both by x. So now that we have that, that's what I like to think of as taking out. I'm taking out the 5x. So what I'm left with is just x here plus 2. So if you think about this, again, it's in the reverse. Let's check to see that we did it right. What's 5x times x? That equals 5x squared. And 5x times 2 is 10x. So again, you see how it's kind of a distribution in reverse? But this is what we were looking for. That's what we wanted, okay? Because we're factoring it. But that was just a way to check. Okay. What do they all have in common? Okay, well, I know you can at least divide them all by 2. Can you divide them all by 4? No, because 6 cannot be divided by 4 or 14. So far our GCF, I want a smaller, okay, is 2. And then they all, since this one only has 1x, they can only all have 1x. Okay, so 2x is our GCF. So we're going to take out 2x, and we're left with, so we know 2 times 2 is 4, so that's what we need to put over here. And x times x to the 4th will give us x to the 5th. Now we need to figure out how to get to 6. So 2 times 3 is 6. And then x times x squared will give us x cubed. Plus, okay, we need to get 14. So 2 times 7 is 14, and x is already there, so we just need it to say as that. And last problem. Okay, so what do they all have in common? GCF. Okay. Both divisible, okay, they're both divisible by 2, but is that the highest one they're both divisible by? No, they're both divisible by 4. Okay, and this one has a squared, but that only has a, so we can only pick a. That has a b, and that has b squared, but we can only pick b. Oh, they both have c squared, so we can use c squared. Okay, so we're going to take out 4abc squared. We're left with, okay, well, we need it to equal 8, so 4 times 2 equals 8. A times a equals a squared. B times b equals b squared, and we already have c squared, so we're good. Subtract, we need to get 12. So 4 times 3 is 12. We already have a, so we're good. And we need b times b equals b squared, and we already have the c squared, so we are good. Okay, so hope this makes a little bit of sense. And we'll work on more in class.